All right, everyone. My name is Clinton Hilliard, and I'm the MC tonight for introducing our speaker. We are very honored tonight to have with us Mr. Kevin Robinson. Mr. Robinson is currently the head of innovation and chief engineer at the Shoal Group. He's coming to us from Adelaide, Australia tonight. Throughout his career, Mr. Robinson has taken on various leadership roles that advance the field of model-based systems engineering. Prior to his work at the Shoal Group, he had a distinguished career working with the field of guided weapons for both the United Kingdom's Ministry of Defense and also the Australian Department of Defense. There he held leadership positions on large cross-discipline teams that conducted research and modeling and analysis in the development of those advanced guided weapons systems. Mr. Robinson has been a productive member within the systems engineering community and a prominent member within Incose. He's produced several publications and has made contributions to the Incose Systems Engineering Handbook and related sets of standards. He's initiated and chaired the first annual Mbsc symposium in Australia. He formed and chaired Incose's model-based conceptual design working group. And in 2016, he delivered a keynote address at the International Symposium. Recently, he's joined Incose's Future of Systems Engineering Initiative, or FUSE as they like to call it. He's a part of that team. So with that introduction, I'm going to now turn it over to our speaker. Over to you, Kevin.
Thanks, Clinton, and thanks for everyone at the Chesapeake chapter for the invite. It's an honour to be here. So got the next half an hour or so. As we said, if you've got any questions that pop up going along, please pop them in the chat. Other than that, I'm here for questions at the end. So I'll jump straight into it and share my screen if I get the right buttons. Do you have the Shoal?
Yes.
Okay. Excellent. All right, let's crack into this then. First thing we do in Australia is we like to make an acknowledgement of country. It's tradition here in Australia. So if you could just take a moment to do this with me, please, it'd be appreciated. In the spirit of reconciliation, with our First Nations people, I acknowledge the traditional custodians of country throughout Australia and their connection to land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Island peoples today. I'm actually presenting from the land of the Kaurna people, which with the little red arrow in terms of where Australia is, the closest city to me is Adelaide. So that's where I'm coming from today. So thank you. Today, I was just going to sort of go through some sort of recent research that I've been doing with a colleague of mine, Tommy Liddy. It's based on a sort of number of years of model-based systems engineering experience and research, as Clinton was indicating there with my background, and including some work with David Flanagan as well in this space. But with the recent sort of surge towards digital engineering, I thought Tommy and myself thought it was time to sort of rethink where our original thoughts were with Mbsc, but in the context of digital engineering, and see if there's an opportunity for acquisition agencies, and particularly within Australia. The outline I'll sort of go through, I'll just give a bit more of an introduction to me and probably a bit more on the personal side that we've heard, the motivation for some of this research and the purpose of the presentation. Just wanted to make sure we're all on the same page in the context of digital engineering. So I'll just give a quick overview of that, if I may. Some of the benefits, and there's been a few more benefits published recently on digital engineering. So just go through a few of those. And then what it actually means to have a acquirer-led digital engineering transformation. Talk about some of the knock-on effects or downstream effects to the suppliers and some of the challenges for acquirer, and then obviously I'll summarize and I open up for questions. This presentation is effectively sort of complements the article that Tommy and myself published recently in the Insight publication from Incose on digital engineering, which I think was published in March, I think, or around that time. It's certainly on the Incose website, so feel free to go and have a look and contact me if you've got questions. So an introduction, as Clinton said, got a background on the left-hand side there in guided weapons. It's both British weapons, the ASRAAM missile, worked on that for 12 years, and then the Australian government bought the Lockheed Martin JASSM/LRASM missile, so I worked on that for a long time with the Australian Defence Department. My contribution to Incose is there, bottom right-hand corner. They've done a number of things, including, I guess one of the first things to come out of the model-based conceptual design working group was a whole Insight edition on that topic, including the picture of David Faulkner there, who's one of the Australian senators. He provided as a keynote sort of opening to the edition of Insight. So quite a comprehensive sort of overview of model-based conceptual designs that is there if you want to go back in 2014, I think it was December. So, and so yeah, a lot of contributions, and my keynote is still up there on YouTube. If you want to, what do they say these days? Go and like and share it. Maybe just join the Incose YouTube to see more videos. And then the pictures of me, obviously being out here in Australia, we like to get out in the outback and into the oceans to swim. So there's a couple of pictures that of myself and some of my family members. So something we like to do is really get out there in the wild. So that's just a kind of a little bit on me, so you know who I am and what I get up to, as it were. But a little bit about Shoal Group, so to provide that context to you. Yeah, complex systems design house, really supporting government, industry and research agencies. So quite a broad sort of remit from supporting government in terms of acquisitions, but also supporting industry in terms of things like establishing, engineering management systems, or actually leading some of their systems engineering activities. And then it's also supporting research agencies in delivering things like proof of concepts or prototypes with our digital engineering expertise. And in the company, we've got about 70 systems engineers with a broad range of skills, as you can see there, that sort of cover the whole sort of systems engineering approach. Some of the, excuse me, some of the recent successes from Shoal, as you can see, we get involved in many defence aspects, but also transport. Off the top left, the current Hunter class frigates that have been developed in Australia. You know, we provided a significant systems engineering effort into defining and identifying the requirements for those frigates. And then bottom left, we've got the Chorus project, which is really around digital engineering for a proof of concept. It's a communication system with a coaxial RF optical communication system, so a real challenging sort of research project, and we're doing the digital engineering on there, along with a number of members of academia and other research agencies. But I always like to go to the Kiwi Rail Inter-Islander one. That's surprisingly more complex than you think. It's basically in New Zealand, the ferry that goes between the two islands. And so it transports people, road traffic, rail, and in quite a complex mountainous region as well. So it's not only complex in terms of what the system needs to do, but a complex in terms of that integration, the broader area, the transport systems and the environment. And so, yeah, we've been making some key savings, I would guess, and insights on that project. So real interfacing problems. So they're just some of the examples, and particularly where model-based systems engineering has had some real success. And so, yeah, model-based systems engineering, and specifically digital engineering in Shoal, we, as Clinton indicated, we contribute a lot to the body of knowledge in this space, and are always pushing out research papers and the like. And we started our model-based systems engineering back in 2005 with our first real-world project, where Defence actually worked with us to do an Mbsc approach to defining the system requirements. So, and that was back in 2008, I think. So had some real successes with Mbsc. But that's enough about me and Shoal. Let's just get into this presentation. What's the research motivation here? I guess my professional motivation is to see the benefits of digital engineering realized earlier in the life cycle, and hopefully you'll realize why I've got that motivation by the time we come to this end of this presentation. I guess from a professional motivation, one of the cases that David and I and in Shoal we look at, because we're trying to keep things unclassified, is, conceptually designing things like bushfire response systems or capabilities. It's a bit of a motivation for me. We've had a number of significant fires in my local region over the last 10 years, where a lot of properties and lives have been lost, unfortunately. And so anything I can do to help that along for me is a good thing. And also I do enjoy the thought-provoking collaboration with David. So for me, these all things come together to help drive my motivation in this space. So the presentation purpose today is about presenting the case for acquisition agencies to not only adopt digital engineering, but to drive that adoption of digital engineering more broadly across the whole of the life cycle. And for me, acquisition agencies, wherever they're from defence or transport, their goal is to ensure that systems engineering is delivering the outcomes they need and effectively, I guess. And they're also responsible for initiating that life cycle to engineer a system. So, that's the case I'm going to put today, that it's about, encouraging acquisition agencies to adopt and lead digital engineering. So what is digital engineering? And hopefully you're all aware of this, but I thought I'd just, put a few slides together to make sure you're on the same context as me. I guess, digital engineering has sort of grown over the last few years, maybe kick-started by the digital engineering strategy that was released by your Department of Defence. I'm sure you're all aware of it. But as time has moved on since 2018, there's, that growing trend. There's a number of publications coming out from a number of agencies and the like. And so, it's there for us all to see. And it's an area we do need to embrace. What is the scope of digital engineering is always a good question. I guess if you look at the SE book that we're probably all familiar with, it covers many elements, including systems engineering, but also, includes other areas, like the product line and things like that. So digital engineering for me is a little bit more encompassing than just systems engineering. So that's, off the SE book, and also on the SE book, it covers all the life cycle stages. But today I really want to sort of focus on that exploratory and concept phase as described here in the SE book, and with a little bit sort of a step into the development phase, particularly around that high level systems architecting. So that's really what I want to focus on today, those early sort of life cycle stages where we can benefit hopefully from digital engineering. So what is digital engineering? There's two key concepts for me. First of all is the digital thread and the digital twins. Those are the terms that get talked about a lot. A digital twin for me is a journey. Twins are a representation, of virtual or digital representation of the system at hand. And that can go from, right back to the beginning of the life cycle and those concept phases where you're thinking about, what is that high level concepts, system requirements define what the concept's going to be. You then sort of move into that prototype in the virtual world, production twins and service twins. And I'm sure there's a lot in between. And the digital threads are really those digital connectivity or traceability between the various different information items that support those digital twins, such as prototypes, production or service twins. And so that's kind of how I think about it. And just to dig in a little bit further and with a couple of examples so we're on the same page, the digital thread, is really that sort of single line that connects various information elements within those digital twins and through that unifies those interrelated data sets that underpin those digital twins with that real-time synchronization. So when some authority updates a data item, it then gets reflected through the rest of the digital environment. And across that enterprise environment, not just bespoke to a specific discipline or a specific organization. I guess that's the ultimate goal. And then the digital twin, as I say, is a virtual representation of the system at hand, and whether that system is the prototype or the production line system. You know, it's what is those information that needs to flow between those different digital twins. And so as a simple example, and this is really where, you know, I like to focus my research. You know, the bottom right hand corner there, we have our system requirements that come out, but where do they come from, and what's the rationale for defining those, that concept that is described in those system requirements? And so, you know, really the digital thread, you know, those requirements come from functions. Those functions influence what the actual system components are, what the requirements are, what the constraints, and they come from the needs. The needs come from the concept of operation. The concept of operations comes from government strategy and policy. So, you know, quite quickly from a system requirement, you could easily trace it back to a government strategy. But because we're on a design approach, we're talking about design approach, you start with a government strategy. We need a ferry between two islands, as the use case I described there. What does that actually mean? What is the concept of operations? What do we need from the system? And therefore, what functions do we need? And therefore, what system requirements? And those functions and requirements really describe that concept or the high level architecture of that system. And so that's what you know, that red lines there in this diagram is that connectivity. Obviously, I've talked about the digital twins, and there are many more than I just mentioned here. You know, but really it's around making sure there is a fit for purpose virtual representation at that particular point in the life cycle, and those decisions made through that virtual or digital representation are then through the digital thread transitioned to other digital representations that are needed through the rest of the life cycle. So there's some examples again of the kind of digital twins that as examples. So some of the key concepts for me, just four that I was trying to think, how can I just nut it down to a few here? The digital engineering concepts that I always think about, you know, the digital engineering and that repository of model repository, for as people call it, is really that current collective understanding. You know, there's an authority on those elements of information, but it's that collective understanding across that whole repository that is important, and it's that single source of authoritative information. The information elements then therefore need to be connected. You get that real-time synchronization, and every information element is traceable to somewhere else, and therefore you can understand the rationale, the context, the decisions that have been made to that information element. And that model needs to be provided to all the teams throughout the life cycle. As I say, we don't want, you know, disparate different models being represented. And the important thing for me is the consistency in the information that comes out of that digital world or enterprise, whether it's documents or other artifacts, are all consistent. And so there, for me, is some of the key concepts that come out of that. And that leads to, therefore, you know, what are the benefits of digital engineering? And I wanted to pull a quote from one of my team members here in Shoal, and I quite like it. Digital engineering solved the problems that you never knew you had. And that was a quote from Tim Carter, one of our Shoal engineering leads. He made that point, and I thought that's really good, because doing digital engineering effectively, it doesn't hide your problems, it stops them happening. So it is the goal, and hopefully you'll see that through the rest of the presentation. So yes, that's the main benefit for me. But, you know, ranging from the digital engineering Department of Defence strategy there, top right hand corner, there's been a number of publications recently. You can see one there on the page. And the conclusion from a number of those publications is it's perceived benefits of digital engineering and Mbsc now. I guess it's hard to quantify the actual direct benefits. It's more a qualitative approach through interviews and the like. So, but some of the key topics coming out of these publications are that it enhances communication, increases traceability, it reduces errors, improves consistency, and it gives everyone a better accessibility to all the information. If you ask me, and I guess you are today, Kevin's view is it gives us a better ability to elicit, structure, capture, communicate, and analyze the information on a system being engineered. You know, when I've seen systems engineering processes being run historically, and I'm sort of going back to my early guided weapons days, you know, it was all in documents, and you know, and therefore, whilst it's structured according to paragraph headings and the like, it's still unstructured information. It's still difficult to make, you know, trace information. It's difficult to actually analyze that in a document. As one of my colleagues here in Shoal used to say, you know, back 20 years ago, you used to have someone that was the document manager, and they would know exactly how to trace a piece of information through the document suite in a systems engineering project. But you're talking thousands of pages, obviously, and that was their sole responsibility to trace information, or you know, and that's something you can't capture in your mind, and you have to have someone to do that. So having the traceability in that digital engineering world is a good thing. So. You might have seen this diagram on the top right-hand corner before. I sort of went back to the source on this, and it came from a 1992 UK National Audit Office report, where they indicated that 90% of the life cycle costs may be determined by the decisions made before production of a new weapon system begins. In other words, 90% of the decisions are made before we start cutting metal, as they used to say in the olden days. So if you look at the graph, the concept definition phase is there, and you can see the evidence that was collated by the National Audit Office in the UK. So you know, if you are going to change and drive digital engineering, that's the obvious place to start, and obviously that's the acquirer's responsibility of that. Those, you know, given those committed costs, 90% of those costs then go downstream to the supplier, and the supplier will see the benefits of those decisions made. And if those decisions are made in a more robust way because the data is connected, it's traceable, you can analyze it, communicate it more easily, then that's going to be a better outcome, I feel. So what for the acquirer? If you look at the research that is out there, you know, looking at things like Eric Honors or Steve Cook's papers, you know, that the higher proportion of their budget is spent on mission. Sorry, I'll rephrase. For successful projects, a higher proportion of their budget is spent on mission definition and requirements engineering, and that's, you know, from the analysis that's been able to be quantified. In other words, there is a better concept definition. So the immediate benefits, you know, to an acquirer who's responsible for that would then flow downstream, you know, and if we particularly pick on the acquirer's perspective of those benefits that are perceived, you know, enhanced communication. Well, you're enhancing the communication of the problem space. That's the context for which the system is sitting in. As a design engineer, I know that I want a better context and an understanding of how decisions have been made to that context and the rationale behind them. I can then trace it back to the strategic need. It's not just a set of requirements that I'm trying to address. I can actually trace it back to, you know, the operational need, the activities that the military or the acquisition, the owners, the users want to do, and even strategic guidance. There's that real traceability and now I can make design decisions according to that more strategic needs. Obviously, as a supplier, I want to see a good set of requirements, and if digital engineering and model-based systems engineering reduces that error rate in the requirements, that's a better thing. You know, this is an area here that I'll talk about that David and I have been working on, is that improved consistency between the upfront requirements definition and the test and evaluation space. So, you know, really improving that consistency and how we consider both, and in Australia we call it above the line, you know, acquirer perspective, acquirer owner perspective on the system. So, you know, making sure there's consistency between the concept definition and test and evaluation. And better accessibility to all stakeholders in this process. You know, if we start with the government or acquisition agencies, then that flows downstream to the supplier, that accessibility. So for me, the best place to start, or where the greatest return on investment, is in those early stages of the project. So what is an acquirer-led digital engineering transformation? So I guess there's two roles here, two roles of the acquirer. First is if they can actually start to deliver those data-centric artifacts, whether they're models or whatever, that are needed downstream for the digital engineering across the full life cycle. And as I said up front, that model-based conceptual design is a very good place. It's probably not the only answer, but it's something, from a model-based systems engineering perspective, generally in industry, they start with a set of requirements that have come from the acquirer. Why not connect to that to the model-based conceptual design that the acquirer did? Anecdotally, I've heard that an acquisition agency has done some model-based conceptual design. They then, from that model, published the document, which was the requirement set, because that's what the lawyers want through contract negotiation. That then goes to the supplier. The supplier then builds a model based on that document. That seems very inefficient and ineffective to me. Why not just hand them the model, And so, the acquirer has that responsibility to start using data-centric artifacts in the form of maybe model-based conceptual design. And then there's also that leadership and governance and control perspective. Be ready to accept and use those data-centric artifacts. Don't expect a delivery of a document, expect a model of the system architecture, for example, and standardize and define that data-centric approaches and structures to apply. I think that, from my perspective, that's what industry and suppliers need. There's many different approaches at the moment. So, standardizing that approach will help all industry. And so they're the two sort of roles as I see it for an acquirer. But, and I guess it all starts with that model-based conceptual design. So I'm just going to sort of jump into that for a moment or two, just to give you my perspective on model-based conceptual design. So I guess this is the process that we've run with many acquisition agencies here in Australia. Up front, there's some strategic work and operational experience that needs bringing together. But what we do is we work in a model-based way to really go through that sort of loop there and understand the stakeholder needs and capture in a modeling environment those strategic goals, the capability, high-level capability requirements, and go through that operational analysis and operational experience to really start to unpack and understand what the stakeholder needs across all aspects, not just the deployed system, but the maintenance system, the training system, or as in Australia we call it the fundamental inputs to capability. And from all those user or stakeholder needs, we then sort of go through a model-based systems engineering approach to define what the system functions are, look at the components or alternatives that you can see out there either in the marketplace or that needs to be developed, and start to define that architecture. So at the end of that process, we end up with that solution or high-level solution concept that then can be defined in a set of system requirements, and then it obviously goes out to industry for system development or purchase and adoption or whatever. And so, across the bottom, you see that virtual environment there connected with that digital thread, and that's what really enables us in that conceptual design cycle to realize that requirement to strategic guidance perspective. And this is a bit of a noisy slide, and I do apologize for that. I didn't want to go into it in any detail, but just to give you that feel, this is kind of what we've done to we use one of the many Mbsc tools that we use to do this is Vitek's Core historically, or their Genesis tool. We use all the other Mbsc tools, whether it's InnoSlate or Cameo or others, but we always implement this meta model because this is the design process we like to see for model-based conceptual design. And down there, the highlighted in yellow is the requirements that come out of this process. But like I just sort of indicated on the previous slide, where do those requirements come from? There's many different paths to help influence those requirements, and I've just picked on one particular one that goes back from those requirements to the system functions and the system components. Those functions then go back to the needs and the operational activities. Those activities go to a high-level vignette or scenario. That then traces back to an operational task that needs to be undertaken, and then that then gets back to the mission. And that mission is related to the strategic guidance that's required of this capability. And whether that's an inter-island, a ferry, or some sort of coaxial communication system to a satellite, the process is the same for us when you're conceptually designing the system for an acquisition agency. So, the return on investment, as I mentioned previously, Eric Honor's work in there, and I hope you've all seen it, that the sweet spot is around, I think it's around 14%, but let's call it 15% of our project budget should be spent on systems engineering to give the best, most successful outcomes from the project. And his research goes on to say 40% of that spend should be spent on the mission definition, requirements engineering, and system architecting. And I'm just sort of reference that UK National Audit Office graph again. So really, that says to me that 6% of the budget should be spent wisely in that front end of the systems engineering life cycle. And so I've just sort of jumped into a couple of examples here from a Shoal perspective of the things we've done there. Getting into the system design. We through our traceability and structure within the modern Mbsc environment. We find that structured approach to connecting those business goals or the mission goals to the operational perspective, and we look at structuring that approach to identify the needs and requirements. And therefore, we can immediately, through that approach, analyze those the coverage of those requirements to the operational and business goals. And so the benefits are that, that Mbsc, because you want to flow it downstream into the supplier side, provides that basis, a really robust basis for further Mbsc efforts, throughout the life cycle. And you can trace those efforts that are going to be done by the supplier back to the business case, the original business case that the acquirer put to the government agency or whatever agency it was for the funding. And so in the design analysis part of it, you take this Mbsc approach prior to the system requirements, you can really understand the scope of the system and how those functions can break down to specific users and really do what the acquisition agencies have a specialization and understand those interfaces, not just the system interface, but interfaces to the training systems, interfaces to the maintenance systems, as I indicated earlier. And you can really get into some detail around analyzing the scenarios. And we Shoal would do a maintenance scenario. So if you're taking some sort of armored personnel vehicle for defense, when it's not operational, how do we take it out of whatever mission it's on and put it through the maintenance system, and how do you actually manage that and the like, and allocate resources and understand what the requirements are going to be on the maintenance system. And therefore you can start to allocate performance budgets if resource is part of your performance, and so you can really do that and start to do that high-level conceptual design analysis before you start to commit to contracting the requirements. So again, it provides that basis for further enhanced Mbsc efforts and provides that traceability. The analysis provides that traceability still to the strategic guidance that's coming through. And you can go to the next level, obviously, as you all know, in the Mbsc world, you can start to get really into that logical architecture and understand the options for solution components and how you might consider them, particularly, from an Australian government perspective. They do a lot of buying of overseas, sorry, I'm talking about defence here, overseas equipment, so they can actually do some high-level sort of component analysis. You can start to really define those interfaces to the maintenance or training systems and other, operational systems, obviously, and look at all the different sorts of budgets. So this is the kind of analysis that we do on behalf of the acquirer. And again, it provides that basis for the further downstream benefits of Mbsc efforts, and are always traceable back to the business cases. So in terms of the actual direct benefits to the supplier, keep talking about those downstream effects. What can we see? From the research, if you look out there, and just the acknowledgement in the top right-hand corner, these are directly applicable to sort of any organisation with any level of maturity that we see out there. And the benefits to that supplier can be seen as early as the tendering phase. System data being passed between an acquirer and supplier. It's gonna, if you've got it, to use those perceived benefits earlier, if you've got it error-free and more consistent, you know, you're immediately going to see it during that tender phase when the acquirer directly engages for the first time with suppliers, you know, and so immediately you're going to have that kind of better alignment of expectations. And hopefully, and obviously no evidence on this, you know, you can reduce that likelihood of project scope change, which is always a challenge. I've been in a number of contract negotiations, and it's always a project scope change, and hopefully you're going to reduce that. And so, you know, going back to those perceived benefits, those two key benefits that come out of the tendering process, you know, are really for me around those perceived benefits that have been mentioned in the recent literature around, you know, the reducing the errors, improving consistency, excuse me, consistency and better accessibility. And that shared understanding is really key. You know, as I mentioned earlier, that current and collective understanding, and the research that I've sort of looked into, you know, one of the key root causes of problems with acquisitions is the understanding between the acquirer and supplier. You know, the initial defined understanding, and you know, that through the tendering process, and I know that's not the only way, is those set of requirements. But if you can provide all that context to the requirements, you're immediately giving better understanding to the supplier through, you know, enhanced context setting, understanding the decision rationale and the like. So really that understanding is what's required between the two organizations. Like with any collaboration, whether it's contracted or not, that's what you need to do. And so, you know, for me, some of those benefits for the supplier is the fact that if the acquirer undertakes an Mbsc approach or digital engineering approach, then that gives you that understanding. You know, you have that traceability for when the supplier makes those design decisions on particular system, you know, system components or like, you know, got that context for it. And hopefully, you know, it would lead to a better verification and validation. You're getting key insights of what the user needs are early, and therefore, you know, that verification and validation at the end of the life cycle, you can sort of start to consider that early. And therefore, you know, that reduced project risk, improving understanding is really where we're heading between the supplier and the acquirer. And it certainly doesn't come without its challenges. If you look into the literature, you know, even for an acquirer with that mature digital engineering capability, you know, having that, you know, single source of truth, or as it says in the Department of Defense strategy, or that current collective understanding, as I like to consider it, you still, in this relationship between acquirer and supplier, you still got challenges of data protection, the standards being used, and the maturity of some of the data-centric tools. You know, from an acquirer, supplier, or acquisition perspective, it's a very competitive environment. There's some very big numbers when they talk about costs of systems, as we all know, whether it's defence or transport or anything really. There's some big numbers talked about in terms of the costs. And so that really sort of, that competitive environment really mandates a careful control or protection of data. And it's whichever way the data flows. It's not, you know, one way or the other. It's both ways. You know, there's some strict probity requirements required during acquisition phases, and the supplier will really want to protect their intellectual property and also their commercial information on how they're bidding this. So how do we address those challenges? And that's, you know, I guess something that's work in progress within the community. We also see that many different standards, there's this publication from Williams et al. Sort of indicated in Incose's workshop last year. There's many different interoperability standards across that digital engineering environment. I'm not just talking about Mbsc tools, but I'm talking more broadly, whether you're going into CAD tools and product line management or whatever it is. There's many different interoperability standards, and there's many different interoperability bodies that are trying to make those standards. So, and I do fully acknowledge that Incose have got a big effort in space through, can't remember the name of the working group, but there is a couple of working groups in this space. So, and all of that will require alignment if we're really going to realize the benefits of digital engineering. And if we start at that early phases and then flow it through, whatever that approach taken in the concept phase would then need to flow through all the other environments as well. So there's some big challenges ahead in this space. And also the maturity of the data sets, from my perspective, there's a number of, even just in the Mbsc environments, there's some maturity needs to be sort of developed in this space. But digital engineering reaches across many different disciplines. And so, the maturity of those tools need to be raised through that standardization and things like data protection approaches. And digital engineering, because we're trying to go across the whole life cycle here, it does have a diverse set of tools. So it's going to be a problem for all the tools. How do we push it out of their discipline to embrace the other disciplines through that digital thread? And yeah, so it's applied across all the aspects of the life cycle. So I think there's still a long way to go on that space, but it's, I'm watching eagerly in the tool market, and I think it will come. And we're on this sort of crawl, walk, run, launch to the moon kind of trajectory, and I can see only good things coming from it. But again, it's work in progress, I guess. And I wanted to sort of go back to a publication I remember reading in 2016, and I sort of pulled out a quote here that sort of just summarizes those challenges for me. And this is something from the Aerospace Industries Association they published when Mbsc was just being talked about back then, and reaching out into the broader sort of engineering community, but it's still just as applicable today with the digital engineering. In other words, govern industry collaborative environments, secure Mbsc frameworks to support diverse tools and control data. And so I'm going to have to move my picture. Control data exchange and develop stable, clear, affordable, non-conflicting program requirements. And so really, if you read the rest of that article, and I encourage you all to read it, it's really around data protection, data standards, and the maturity of data-centric tools. Obviously, they talk about it from an Mbsc perspective, but that's sort of kind of where they're at. And so just to kind of wrap this up, with a bit of a summary, when we look out there, I see an increasing adoption of digital engineering, or the push towards it beyond just model-based systems engineering, which is great. It's good to see. And from my perspective, and hopefully I've put that case forward today with the evidence that's out there in the literature right now, there's a tremendous opportunity, a tremendous benefit if we start applying digital engineering in that concept phase, because it then permeates not just that phase, but also the latter phase or the later phases of the systems engineering life cycle. So, and driving that lost my tongue there. Driving that digital engineering sort of transformation, for me, the greatest return on investment is in the hands of the acquisition agency. Not only the leadership and governance and control of digital engineering, which we are seeing here in Australia, the demand through contracts to use for suppliers to use digital engineering, but also to lead by example and initiate the supplier side of the systems engineering lifecycle with digital engineering. So really, it's for me, the acquirers should be making the first move, and that's something I don't necessarily see more holistically. I know industry is fully embracing this because they can see the benefits. So with that, I'll pause and thank you all for attending today. It's a pleasure here to present, and so looking forward to questions and comments. I know we've got some in the chat already, so Clinton, how do you want to handle this?
Feel free to, if you can read the chat, that's fine. Or if you want to call on these folks to vocalize their questions, that's fine. That people can unmute themselves if they want. I think the first question I see is from Dave Fadley there.
Yeah, I'll just looking through. So thanks for your comment there, Clinton. You love the quote. Yeah, I did as well. That's why I put it in. So thanks. WSAF, yes. Sorry, acronym there in the hidden in the text in that background. Weapons. Sorry, I'll rephrase it. Whole of system analytical framework. It's something we've developed here in Shoal in partnership with Defence. In other words, the underlying schema or meta model that we use here in Shoal. So that was the whole of systems analytical framework. Okay, so yeah, one from David. What's been your experience with the big challenge of keeping models up to date and accurate so they are trustworthy? Yes, it's a constant battle. What we see, I guess, supporting the acquisition agencies is we see initial surge where they want to build the model, get it to a point where they can start to produce the correct artifacts they need for their contracting, approach going towards suppliers. And then obviously, as you get closer to decisions, or there's some sort of new aspects, we then go into another sort of modeling updates. And that's one of the things we certainly see, that if there is a change that needs to be done in that acquisition side, because they've had some engagement with some of the suppliers, let's say, they can say, oh yeah, it's these functions, these are breaking the laws of physics. I'm making an example up there. They're breaking the laws of physics, and then the acquirer with us has gone, okay, well, that's not right. Let's follow that through. And you can immediately see the cascading or the impact on the rest of the context, and trace it through to its root cause of something that's incorrectly quite quickly. And so that, for me, that's one of the benefits of it. If you see a mistake, you go and trace it through. So we work with them across their processes, and we update the model as changes are seen fit by particular experts in particular areas, whether it's an acquirer expert or a supplier expert. So it's an ongoing process. Hopefully that answers that question. So David's got another question. What are some real-world example of critical issues important to the customer? The model helps to resolve. This helps to sell systems engineering and challenge for many of us. I guess one. How do I talk this? Yeah, this is quite a tricky one, because there's an issue of protection of data here publicly. There was one example that a recent one would have been about a year ago. They were taking a document-centric approach to this particular acquisition. It was challenging. It was a transport job. And they realized they were getting into a bit of a hurt with the project because it was all document-centric, quite complex. We were asked to come in and do a tiger team, as we called it. At the time, it was a quick look, what can we do to help in the model-based systems engineering way? We immediately started looking at all the documents and saying, no, this is the mess, we can't understand it. Let's start to pull that information into an Mbsc environment. We started to do that. And within 3 months, we sent a letter to the head of that organization indicating that if they didn't change their conceptual design that was articulated in the documents, it would cost them at least another $1 billion in their acquisition. So I unfortunately can't talk more than that, but they had a real trouble with the way they were interfacing to some of the other systems, and it meant there was going to be a huge change in the other systems unless they considered design change or conceptual design change in their own system. So that was the cost that they were going to bear to that other system. So that's what it's going to cost them, an additional $1 billion for change. So hopefully that's a nice, easy example, gives us a points. But yes, some of the benefits there from model-based systems engineering, there was obviously an error in their conceptual design. Sandy, your reference to Eric's honours analysis on this systems engineering, losing my tongue, systems engineering percentage for successful project at 15%. Do you expect that percentage to be maintained in DE, or do you expect the cost reduction for systems engineering and DE project? That's a good question. Yeah, I guess because digital engineering is more holistic, then if you're starting to look at digital engineering percentage spend, that would increase. Would we expect a reduction in systems engineering percentage? That's a good question. I mean, I guess so. My experience of being a systems engineer on the supplier side has been, having those kind of discussions between the domain experts where they've got a particular model that they use or representation and the main systems engineering team, and you're sort of having those discussions. if they were connected, you know, virtually or digitally, those modeling environments, it would, I'd imagine, reduce that kind of effort. I'm trying to think of an example. I know on one particular system we looked at, in one environment, they had two different digital or modeling, mathematical modeling environments. One was used to test some control algorithms, design and test the control algorithms, and the other environment was to demonstrate performance or compliance against the system requirements. And the information between those two environments associated with the control algorithms were, I would call, air gapped. In other words, one team would write them in the document of their design, and the other team would then embrace that document into their performance model. And there was a little bit of an inconsistency because one team took something out of the model, it looked okay, it worked, and handed it over to the other team, and it wasn't included in their model, and the performance wasn't achieved in the modeling environment, and so there was inconsistency. So that kind of issue would stop, I guess. So I'd imagine systems engineering effort might reduce a little bit if we did an analysis in another 10 years, or if Eric did an analysis in another 10 years. And what are the most effective metrics to measure DE progress on a project? Oh, yeah, I've had a look at some of the metrics, and they tend to be around things like model completeness and that kind of thing. And that is one way to look at things, but yeah, I don't know. There's some way to go on that. I think, you know, for me, it's about traceability. That's how we should be thinking about it. And you know, maybe there's something about, you know, orphan, information components, or, you know, is there sufficient rationale and therefore traceability documented on that particular information element or something like that? I don't know. I don't know. Work in progress, I guess, if you look in the literature. So thank you for all those questions. Any more?
Thank you, Kevin, for, I want to, while people are thinking whether they got more questions, let's take a brief break here where I want to present my screen for a second, if I can.
Yep, I'll stop sharing.
Sure, I get the right, this one.
Well, is this like Vanna White? We're going to see Wheel of Fortune too?
Not yet, Kaz. You're giving away the secret. No, I do have that. I forgot to mention that. We will be giving out a door prize at the end here, but I just wanted to give our formal digital certificate of appreciation to Kevin.
How appropriate.
Yeah. I'll send you a digital copy of that, all in the spirit of digital engineering. But yeah, we want to thank you for the excellent talk and topic, and the crowd here. I thought they'd be a little more vocal. This was a quiet bunch here. We don't have people like unmuting and.
Well, you can always find me via email, and just hope it's stimulated some thoughts in everybody. But thank you for the digital certificate for my digital engineering presentation.
And if anyone has any further questions for Kevin, now would be the time to ask them.
Hey, Clinton, Dave Fadley. Hey, Kevin. How are you?
Hey, Dave.
Hey,
yeah, good, thanks.
Yeah, he complained we weren't talking verbally, so I figured I'd just verbalize his question, you know. But what software do you guys tend to use for, like, I mean, there's a lot of different ones out there, and one of the challenges is always people are trying to get cheap and free stuff to give them some basic stuff. At least my clients, that's how they look at it, rather than spending a lot of money getting people up to speed and staff and all that. What do you guys use? Have you found anything that's real convenient, like a beginner thing that people can use that's relatively inexpensive or anything like that, that customers and clients can start training on?
Not inexpensive. They all tend to come with a high price.
I know, exactly.
But the one, and I guess I mentioned the Vitek tools. The one we went down that route for two reasons, and this is, I'm talking sort of late, 2005, 6, 7, 8 kind of thing. Back then, we did an analysis of the tools, and we found that those tools were the best for two reasons. One is that the Vitek at the time was the only one that went with a database first and then visualization second. So they provide that approach for the underlying schema or meta model that made the Mbsc approach a lot more structured and rigorous. You couldn't break any rules about how you wanted to display diagrams or whatever. It was all about the model first and then how you visualize and interact with it second. And then the other reason its diagrams are very simple. It's functional flow block diagrams. It's simple hierarchy diagrams. So the learning overhead for our clients and back then it was just the defense space, and military clients were much easier. And then there was also, they could auto-generate documentation, which was really what our customers wanted. They just wanted an FPS. They didn't care how we did the systems engineering behind the scenes. So we developed our own script that generated their functional and performance specification and operational concept document in the format they wanted it. And so we were able to produce those kind of scripts. We did look at all the other tools. I must admit, back then, things like Magic Draw and the like, I used to call them Visio on steroids, because it was a very diagram-centric approach. There was no robust underlying schema that enabled you to produce a traceability chart from requirement through to strategic guidance, with 14 information steps on the way to really understand the context for that requirement. So, and there was a number of other tools I can't remember off the top of my head, but we certainly looked at them. That's where we started. Since then, all the other tools have improved. There's a lot more focus on the model, underlying model, not just the visualizations. But with our military clients and our other acquisition clients, we still go back to the Genesis tool suite because it's functional flow block diagrams, it's lines and squares. There's no graphical language that you have to learn. And that's changing, with time. We're seeing more people who've got, in our acquisition agencies, who've got Mbsc experience, for example, and SysML experience. So it's changing with time. But yeah, sorry, can't really answer the cheap question other than using Visio.
Right, Visio and PowerPoint, I know. And
yeah.
What about trust? Do you get the people or your customers, clients? Do they have to build trust in the tools, or they already have because they have experience in it? How do they learn to trust the data and the models?
Historically, it was a challenge, and as I said, what they used to say was just we said we're going to do this. This is the benefits of doing Mbsc, but they said just give me the document. That's all I want, kind of thing, because that's what they had to push for their decision processes. But in terms of trust in the model, we're seeing a growing trust and a growing desire from acquisition agencies to do Mbsc. They sort of know they know the benefits of it now. It's less of a challenge for us. We don't have to go through that, sales pitch on Mbsc. It's like, oh, you're using Mbsc, great, let's crack on, kind of thing. So there is an inherent challenge now, and from their perspective, whether it's a document or an Mbsc that produces a document, the document still goes through the same review processes, and that they feel more engaged with the Mbsc approach because they actually get in a room with us. And I remember the first time we did this, as I said, the twinkle in the acquirer agency's eye, as it were. They got very excited that when rather than having to whiteboard stuff, they could see the information change in an Mbsc environment in front of them. We used to put the tool in front of them, and in terms of a functional flow block diagram, describe their operational activities. We actually used to put that in front of them and say, this is what we think you do when you go and, fight this sort of mission. And they go, oh, no, hang on. No, that comes first. And this is in parallel to this. And, we change it literally in front of them. And they have then had the confidence that the knowledge that's in that Mbsc environment that then gets pushed into the document is there. So we found that quite trusting approach from them, and that would sort of really get them, and they go, oh, they get really excited about it, you know what I mean? So embracing them in that process of generating the knowledge through the model was always the best way to build trust, I thought.
All right. Thanks, Kevin.
That's right. I'm just looking at the chat.
Yeah, I don't have a question per se, but I just say that this is, you know, stuff or material I've seen ongoing for, you know, the past 10, 15 years or so heading in this direction. And this is really good. And that's why I've gotten involved myself in the Mbsc and modeling area, modeling simulation as well, but with these new tools and things like that. But it's not, I guess when Dave was saying about something, you know, inexpensive, I mean, you know, might be some things out there like Capella or some other OBO or whatever that might be free, but there's still a high cost of any tool, just learning that, yeah, you're not just doing a visual drawing per se, but now you're taking this and you're actually making the connections is where the modeling comes in, and you're doing the design behind it. And that's learning some of that, even though you maybe got different manufacturers of tools, but basically you still need to know how to do that and know that that takes some time and some thought on how to do that. And that's where the engineering comes in behind it. I mean, if you set up all your elements and say, here's all your connections, okay, well, once you do that, you can get a high school study almost to go beat it into the tool. But somebody had to sit down and figure out what all those connections were, et cetera, et cetera. But I do see where you're talking about being more in the acquisition area. And that to me is, yeah, I guess a natural expansion that you just keep broadening this out because, you know, you say, okay, we're starting at position 1 here. Somebody's got an idea, and then, you know, they can go, no, you had to be at you know, start position -1. When I worked at one company, that's what they would do, because they said, look, before you do some of this, you got to get the right people in the room to even start gathering up, you know, this material before you can even start, you know, putting ink to paper. We're still in the pencil and napkin area or something before you even get up to that step 1. And I was always amazed by that. But now with the digital world that we have now, that can be, you know, those materials can be rendered easily and finally connected, and then that way you can do your prototyping, et cetera, et cetera. So it's this is really getting more and more sophisticated, and it's very interesting. And I think when you had your drawing there going to the spaceship, you maybe needed to show that, yeah, even though it doesn't look like we're moving very fast, when we step back for the past 10 years, and then you can see, you know, the exponential growth going on, and that's where we're headed. And I really think that this material is paramount to get us going on that. So very good talk, very good.
Thanks, Mark. Yeah, and I certainly agree. I mean, as I mentioned in the talk, that, you know, the anecdotes that we're sort of hearing from people where some acquirers are doing Mbsc and then they produce a document, it goes through all the lawyers and the contract negotiation, and then the supplier builds their Mbsc model based on that document. That we've certainly heard that, but the last couple of years, once someone is on contract, the acquirer has passed across the modeling. You know, so we are starting to sort of see those kind of thoughts. It still has to go through all the lawyers, and they like documents, unfortunately.
I've got a question, Kevin. So a lot of this has emphasized the importance of doing this process quite early. In a situation where you've got multiple companies bidding, it's a competitive situation. You've got the requirements from the authority coming in to multiple participants, one of which will eventually be down selected. You actually have to do quite a lot of work on the requirements, mission analysis, functional analysis before the contract award stage. And it seems to me that it can be difficult when the authority ideally should be engaging in this model-based process with the suppliers, but there isn't just one supplier at that point, there's multiple suppliers. But if you leave it too late until the stage where the contract's awarded, then that's probably a bit too late. So how, I don't know if you have any thoughts about this. This is something that's really bothering me at the moment. And because of the nature of the competition as well, you can't have open communications, and you have to do it through questions and answers and things like that, which is not really ideal for the level of collaboration we probably need.
No, I agree with all that. I mean, one of the approaches, and I assume it's the same in similar sort of acquisition sort of environments overseas, one approach they use here in Australia is a request for information, which is, they put that out to everybody and anyone can respond, but you don't get the full, I guess, information suite at that point in time. So, from an acquisition agency, they use that information. An acquisition agency, works with users, works with the other parts of the agency. I know from an Australian perspective, they work quite heavily with the Department of Defence Science and Technology group that really knows the technologies that's out there. And so when an acquisition agency comes to, part of their process defining the functions, hopefully they've got some information sources, whether it's from the suppliers or specialists like in the Defence Science Technology Organisation or group as it is now, to make sure that function that's been defined and the performance associated with it is viable. I guess when I worked in Defence Science and Technology, that was one of my jobs was to test the viability of those performance metrics and those functions using simple mathematical approaches or whatever is required to do that. I guess some things that if you're actually designing a system, they run a parallel kind of how you're going to build this system kind of activity, and then down select preferred tenderer as well. There's options like that as well for actually when you get to the contract negotiation. I know here in Australia we've just run for an armoured personnel vehicle two parallel streams where they said, okay, put a request for tender out there and 2 were down selected, and then they go through that year's activity. And that's maybe an opportunity to refine the Mbsc model from an acquirer perspective and have those suppliers start to integrate with that one model. They're on contract to undertake that year's worth of activity. So it is a problem. I agree.
Thanks. That's useful then, because I think, so once you through the ITT stage and then you've got the down select, I think that's a good time to actually have more engagement. Thank you.
Hey, Kevin, before we close out, I wanted to also wanted to ask you if you can send me a copy of your slides, I can make sure they're available with the video. I'd appreciate that.
Yep. Yeah, I'll PDF and send them over.
Cool.
Sure.
All right, so I'm going to call that a wrap tonight.